However,
Dang it, Sally.
that really wasn't her mistake. So Sally didn't distribute, but Sally didn't really need to distribute. Yeah. However, yeah, if she did distribute, then it might have changed her approach down the line, but yeah, I'm sorry, I opened a can of worms. I'm sorry.
We'll put the worms back in.
Yeah, and honestly, I've never seen a can of worms. It just sounds gross. I just imagine like thinking I'm opening a nice can of green beans. Like thinking to myself, like French cut green beans with almonds in it, like this is gonna be delicious. And then like
A small Russian
can of worms. So we can distribute here. Kill the eighth, right? So we have 2x equals negative 6x plus 16. Next move. Add the 6x. So now we're looking at 8x equals 16. Last move. Divide by the 8. And you get x equals 2. Feel free to check if you want. If you're confident in your algebra, then you don't need to. So. Number 2, first move, distribute. Got 2 instances where distributive property have to happen. 3x minus 9 equals. Oh, this is even better. What do we get in the next step? You guys all right? Have a little too much sugar today?
I have not enough sugar.
Really tired? Yeah, that's all right.
Half a bowl of cereal and I'm dying.
Well, I'm going to give you a graded exit ticket at the end of class.
Alright.
Whether I get to a point where I can actually teach you how to do it or not, I'm cool either way. So next step. Oh, you want it right now? I can give it. No? I thought I heard you say you want it. Next step. Come on.
Add 3x minus. Add no.
Negative 9 and 6 you have to add.
Negative 9 and 6 you have to add. And that would give you negative 3. Right-hand side, I'm just going to rearrange 3x minus 3. So what does this tell us, without doing any more work, that our answer is? All real numbers or infinitely many solutions. It does not mean that there is no solution. It actually means the exact opposite of that. It means no matter what I plug in for x, I'm going to get equality on the left side and the right side. All right? So if I plug in a 3 for x, for example, if I plug in a 3, I get a result of 6 over here. If I plug in a 3, I get negative 2 inside, times negative 3 also gives me a 6. Plug in a 0, plug in a 10, plug in whatever you want, you're always going to get equality, which means all real numbers or infinitely many solutions, but it certainly doesn't mean no solution. The only time you get no solution with a linear equation is if you have a contradiction of some kind, where you get, like the x's cancel and you get 2 equals 0. But that's not true. 2 does not equal 0. So therefore, nothing will work to make equality. All right. Now, inequalities, so that's your greater than, less than, greater than or equal, less than or equal, and then the not equal symbol. We touched on the not equal symbol. That wasn't too bad because we did a lot of the same stuff we would do with an equal sign, just we put a little strike through. But inequalities can be a little trickier. This little component here that you should have seen before, but just in case you haven't, make mention of it here. You're solving your inequality pretty much the same way you would a linear equation, because it's a linear inequality. You have to take into account that if you divide or multiply both sides by a negative number, that you have to change the direction of the inequality. All right? So if you think about it in the sense that if you're negating an equation, you're negating every aspect of the equation.
Sounds like a dinosaur.
Sounds like an elephant with like a stuffy nose. So,
An elephant with severe asthma.
so
So loud.
all that stuff in mind, the process is pretty straightforward. I'm going to subtract off the 10. 5q is greater, not equal, but greater than 10. Divide by 5. So I get q is greater than 2. All right. I'm not looking at a situation where I need to reverse the sign because I didn't divide or multiply both sides by negative. Adding and subtracting, that does not impact the nature of the sign. Only multiplication and division. All right. Now, in terms of creating the graph, so it says express the solution set in words, in set notation, and graphically on the number line. All right, so we have our solution set. We just have to express it the right way. And this is where you might get bogged down in notation. All right, so values of q, so in words, q has to be greater than, or you could say more than, 2. All right, now mathematically that means it's kind of like, if you take it as a literal sentence, it has to be greater than 2. So anything greater than 2. Not just 3, 4, 5, but like anything. So like 2 1/4, 2.001, 2 plus pi, like even weird numbers. Anything, literally anything greater than 2 would be fair game. The way we express this in set notation is to create, do your best, a squiggly bracket. All right, so when you're creating the squiggly bracket, you're creating basically an S, and then you're just going the other way with that S.
I can't do it.
Okay, the alternative to that, create the S, and then go from bottom to top. So you can go like this if you want, but this is the cheap way of doing it. It's kind of lame. You want to try to do it this way. So, yeah, and you don't have this like the weird connection in the middle. It just doesn't feel right when you do it that way. If you do it all in one shot, it just feels like a little bit more artistic. All right, worst case scenario. I'll take it for credit, but I'm going to be nauseated while I'm grading your papers, and like that's never going to be a good thing. All right, so squiggly bracket, Q. So we identify the variable. We put a vertical line. All right, that vertical line means such that Q is greater than 2. And then close the squiggly brackets. All right, so we open the squiggle, we state what the variable is, we put a vertical slash, and we say what the relationship is to that variable. The reason why this seems redundant, but later on in your studies, even in this year, we're going to be working with equations that are in terms of more than one variable. So it won't be like just containing a Q. It might have a Q, an R, and an S in there. So if I'm stating a solution, I might only be talking about one of those variables. So I might be saying Q such that R is greater than 2. You know, so we need to really distinguish what the variables are. All right. Now, in terms of the graph, just make a note on the side here somewhere that greater than and less than symbols get open circles. Actually, even a not equal. Everything else gets a closed circle, so I don't feel the need to mention that. Because I think at that point it's common sense. So if it's not one of these 3 symbols, it's getting a closed circle. Right? So what we do is we look for our benchmark, which in this case is 2. And we plot an open circle at that location. So our benchmark again is 2. Plot an open circle at 2. We're going to shade the number line in the direction of the inequality. All right. This requires the variable when you solve your inequality. It requires your variable to be on the left-hand side. All right. So we don't want to ever have it where it's like 2 less than Q. We want to manipulate it so that the variable is on the left-hand side, and I'll show you what that looks like in a little bit. All right. So I'm shading to the right of Q. Right of the open circle. And it doesn't have to be anything too crazy, just an arrow with a line. Some people like to actually make a really folded in shaded region just to kind of make it feel like it's covering an interval, but this is perfectly acceptable. All right, so for a problem like this, you could pretty much see what I'm looking for. Like on a test, it would be, you got to come up with the solution, tell me what it means, and then graph the results. All right, so in number 2, what is the solution set to this inequality? Well, let's take a quick look-see. What would be my first move here? We could do that. Let's not this time. But for an equation, you'd be fine. For inequalities, if at all possible, try to save multiplication and division for later on down the line.
This man, I don't even think someone playing the nose. They're just playing a trombone.
Yeah, he just doesn't want to be in class right now. So anyway, what do I do here? Yeah, you see, that's what he's doing. So I don't want to multiply or divide, so what's my next step?
So add 6.
Add a 6.
Just like step outside.
The fact that everyone is laughing at a guy blowing his nose is depressing.
Yeah, the world's
Sad.
come a long way.
It's so sad.
All right, so this is much simpler.
It kind of is.
I kind of look at it a different way. It's like you have an individual that really doesn't care whether or not you guys pass it down. So what would I have to multiply this side by in order to get epsilon?
4.
Negative 4. All right, we're multiplying both sides of the inequality by a negative number. All right, when you negate an equation, you negate everything. When you negate an inequality, you negate everything. All right, so x, dang it. X, now this is going to become greater than or equal to a negative 4. All right, so if in an equation we had something like negative x equals negative 2, you know, if I'm telling you to change the direction of a sign by multiplying both sides by a negative number, or when I multiply both sides by a negative number, this would become x, this becomes a 2. If I change the direction, okay, well, imagine my equal sign is pointing this way. Okay, now my equal sign is pointing that way. There is direction to your equality. It's like, is x equal to the 2 or is 2 equal to the x? It's kind of like a score in a baseball game. Is it 7-2 or is it 2-7? You know, it depends on your perspective, right? If you're losing, you might say it's 2 to 7. If you're winning, you might say 7 to 2. Right? But we were always doing this. We just never need to show it because it seems ridiculous to have to show that. Right? But in this case, it's absolutely necessary. Magic. Set in words. X is more than or equal, greater than or equal to -4. I mean, words for the most part. If you use symbols here and there, that's fine. Just the one symbol you don't want to use is the greater than or equal to symbol, because the whole point of the question is for you to show what that means to you. All right. All right, so set builder, squiggly bracket, variables x, such that x is more than or equal to -4. Okay, well, that symbol is not greater than, and it's not less than, so this is going to get a closed circle.
What's the line for?
It means such that. So that,
Like, what, I don't understand. Like,
given that,
Why do we need it? Why do we need it?
what's that?
Why do we need it?
Because it's proper math. Yeah, it's notation, that's all. Yeah, it's kind of, in a sense, in this realm, kind of unnecessary, but it will be really necessary down the line. So at this point, it's kind of like, you know, why do you do push-ups when you're 7 years old? So that it's, yeah, to get ripped. Yeah, so it's so much easier to do push-ups so you're used to it. So when you really need to do it down the line, it's much easier. You know, it's sort of like that. Muscle memory. So we're going to put a closed circle at -4. And I'm going to shade to the right.